Assalamualaikum and hello. Today we will present our MAT575 group project. The topic is about perimeter of Tasik Seksyen 7 Shah Alam. Tasik Seksyen 7 Shah Alam is a man-made lake with an irregular boundary shape. Measuring the perimeter of irregular objects is difficult using basic geometry formulas. This project focuses on estimating the perimeter of the lake by converting its real-world boundary into coordinate data using scale sketch. Numerical methods such as piecewise curve approximation and arc length integration are used to obtain the estimate perimeter. The study demonstrates how mathematics can be applied to solve real-life geographical problems. Now let's look at the literature review. Tasik Seksyen 7 Shah Alam is a man-made lake designed for recreational activities and water retention purposes. It has an irregular boundary, making accurate analytical parameter calculation difficult. So these are the methods. Numerical methods are suitable for estimating its parameter using scale map data. Methods such as discrete least squares and piecewise curve approximation is used to approximate the boundary with polynomials and calculate the parameters through integration. The method produces approximate results due to interpolation, sketching, and rounding errors. The discrete least squares method is used as reference to obtain exact parameters from the map and evaluate the error. Now moving on to the problem, measuring the perimeter of irregular lakes is challenging because their boundaries cannot be represented accurately using standard geometric shapes. For Tasik Seksyen 7 Shah Alam, coordinate points are collected from a scale map to represent the lake boundary. Piecewise curve approximation is used to generate smooth mathematical curves for each section of the lake. And then, arc length integration is then applied to estimate the perimeter of the lake boundary. This project shows how numerical methods can be used to solve real-world measurement problems.
Okay, then for this slide about methodology, we got 7 steps of doing this methodology. First of all is the data collection from our own inspection and from the satellite data. Next, we have to division of boundary into segments, and then we have to do the discrete least sequence, which is piecewise curve approximation. And then we need to integrate the arc length of the perimeter. And then we need to sum of the total perimeter. And next we need to reference perimeter, which is grid or software, and our team using Excel for the software. And last but not least is error analysis. Okay, next for the analysis, step 1, sketching the lake boundary. The shape of Tasik Seksyen 7 was sketched onto graph paper using a suitable scale, and the boundary was carefully traced to resemble the actual shape of the lake as accurate as possible. Okay, next. For the analysis, step 2 is the division into section. The lake boundary was divided into 4 curved sections, which is curve 1 is left curve, next is top curve, next is right curve, and last but not least is bottom curve. This division simplifies the curve fitting and integration process. Okay, next. And then we got all of this analysis about the shape based on satellite, and then the shape onto the graph paper. Okay, next I have to pass to my team.
This slide shows the beginning of the least square we use by fitting a polynomial to get the quadratic function. The picture above is the matrix method, where I is the number of the plot in the quadrant, X is the sum of the X we got from X axis, and Y is the sum of Y we got from Y axis, and the other one, like xi square, xi cube, and xi power of 4 is the sum of x where we power it with power of 2, power of 3, or power of 4. And the picture below is the table where we obtain the function for each quadrant. This slide shows the arc length of each quadrant, which we use the quadratic function that were obtained before and fill it in the general equation of the arc length to find the estimated perimeter. As you can see on this slide, we are listing the estimated perimeter on the left table and sub it and get the value of negative 492.11 cm, which are in a negative value, whereas perimeter is logically in a positive value, so we put a modulus to make it in a positive value. Next, we change the perimeter in a scale of 1 cm of the graph paper to 2500 meter in a real distance and get an approximate value of 1.2303 km.
Moving on to our error analysis, we evaluate the precision of our numerical model by comparing it to a real-world baseline. To establish this baseline, we used Google Maps as a distance measurement tool to meticulously plot sequential pins along the actual shorelines of Tasik Seksyen 7, which give us a true reference perimeter of X on exactly 1.22 kilometers. In comparison, our mathematically approach combining discrete least squared piecewise curve fitting with arc length integration yielded an estimated perimeter of X bar on 1.2303 kilometers. To quantify our accuracy, we calculated 3 standard error metrics. First, our absolute error came out to just 0.0103 kilometers, representing a minor variance of only 10.3 meters over the entire lake. Next, scaling this variance against our true baseline gave us a relative error of 8.442 times 10 to the power of negative 3. Finally, converting this value into percentage gave us our final percentage relative error of just 0.8442%. Achieving an error well under 1% is a phenomenal result. It proves that despite the minor limitation of manual sketching and coordinate collection on graph paper, integrating piecewise polynomial function is an incredible, powerful and valuable tool for solving complex real-world geographical problems. I think that's it. Thank you for listening.